This is a worked example on how to solve an equation involving a power function or a root function. So in this equation, we can see that we have a power to the 1/2. So it might be helpful to visualize this better if we convert this to a square root. Now, you don't need to do this, but oftentimes I think it just sort of makes it clearer what we're trying to do. So this square root is going to make it really awkward to solve this equation. But what we can do is we can raise both sides to a power of 2, and that'll cancel out the square root, and then we'll kind of have a polynomial left over to work with. So let's square both sides of this equation, because whatever we do to one side, we have to do the other. And a square and a square root will undo each other. Equivalently, if I had stuck with the original definition, all I'm doing here is raising this term to the power of 2, and then using exponent rules, I would get that my exponents, because if you exponent an exponent, you multiply them together, and I would get 1/2 times 2, and that simplifies to 1. So it's the same cancellation that's happening, just can sometimes help to visualize with roots better. But either way, we are going to simplify by raising to the power of 2, and what I have left over is this object, or not object, I guess this term on the side squared, but now I'm free of that root from before. So what we can do from here is I can expand this left side of the equation and see what we get, and then we can solve this like a normal polynomial. So I have x squared plus 2x plus 1, and that equals 3x plus 7. Now this hopefully is an equation that we know how to solve, but let's still go through it. So let me kind of make myself some more room here. Let me bring this up here. And we can subtract off the 3x from both sides. So now I have x squared minus x plus 1 equals 7. We can now subtract the 7 off from both sides. And so this is a -6 equals 0. And this factorizes. This factors into x minus 3, x plus 2. And so now we see that my solutions from this quadratic are x equals 3 and x equals -2. But we're not done yet, because we need to check to make sure our solutions are actually working. So let me bring a copy of the original equation. No, I'm going to use this version instead. So let's bring a version of this. How do I paste? Okay. Let's just bring this down then, because I don't know how to copy and paste. So I want to check to make sure that this equation is satisfied by both solutions. So let's take, for example, this solution of x equals -2. And let's see what happens if we plug it in. So if I get -2 plus 1 equals 3 times -2 plus 7. Well, first I can simplify this square root, and I would get -6 plus 7, and this is the square root of 1. And you can see on the other side that -2 plus 1 is -1, and this is not equivalent, but we could even take a faster shortcut than this. If we simply notice that the left side of this equation simplifies to -1, then we know a root function, no matter what I have in here, is not allowed to output a negative value. So if you look at the graph of a square root function, it's going to move up like this, and it has a restricted domain and range. There's no way for this root function to output a value that's going to exist down here on the graph. So this situation in itself is already impossible, and so we can rule out x equals -2 as a solution. Now, you can go ahead and check 3. You can verify that that works. Let's just do that just for example. So I get 3 plus 1 is equal to the square root of 3 times 3 plus 7. This is going to be 4. We will get 9 plus 7, which is going to be the square root of 16, and the square root of 16 is 4. And so that solution works out. And so the entire solution to the function is only x equals 3. X equals negative 2 is not a solution. It's called an extraneous solution, and so we do not include it. So the general process for doing these problems is not incredibly complicated, but you do want to make sure that you're checking your solutions, because it is possible for something to escape and seem like it's a solution but not actually be one.